Alright, how's everybody doing? Yeah, that's better. Yay! Alright, let's do some more Vulkan. I made a Git repo. Alright, so if you want to follow along, that'll be what I'm going through. And then I'm going to switch to Linux. I'm kind of liking doing this in Linux. Kind of mostly because I'm curious about like Vulkan's capabilities on Linux. But I'm also kind of curious about that DXVK project. Like, do you just learn DirectX and then you're done? And just use DXVK? So anyways, Linux time. Okay. Oh yeah, I have to check these. Wow, are you kidding me? The audio is almost as big as the video? What are you talking about? I may have to go see if I can tweak that libopus output. That's terrible. Actually, let me see. Let me just tinker with this real quick. Yeah. Wait, why is it? Oh yeah, because it's recorded as a WebM. Well, I always wondered that, why the video on an MPD has to be encoded as a WebM. Yeah, I wonder if this is technically a video. I have to look into that. Actually, let me write that down. I wonder if the way it synchronizes it is it's actually literally playing a video, like two videos at the same time. For those who don't know, basically I'm doing some upgrades to how I do my videos on my website using Dash and WebM, and the way that they want you to encode audio I think is like really inefficient because it's doing libopus should not be that big for that video, but maybe it is. Okay, I'll research that later. Looks like that worked though. Okay. Alright, so we have a whole bunch of stuff, and I created the that. Right. And let's confirm that's actually Git. Okay, cool. And just to be sure, let's do a reset. Hey, Racing, how you doing? Okay, I want to do, now my volume is back to where it should be. Awesome. Let me do a bit of reorganization. Okay, we're in business. Okay, and VK, well, I have to, hold up. I think in VK engine. Yeah, here we go. This is where we stopped. Okay, let's continue. Make sure I can do a build. Shrink my face down. I'd really like to get rid of those warnings on that project. I don't know how to specifically disable warnings on it though. Probably have to do like another Yeah, so let's go and fix our own. There we go. Let me see. Hey, Riven Main, how you doing? Unsend int to unsigned int from int. Okay, a little bit fast and loose with this, so let's do. And I have no idea why do that. That's so stupid. Okay, let's get rid of that one. I think I can't even do that. Okay, so I'm not sure why it's got an issue with this. I wonder, oh, you know, I bet I'm using it. I'll do that. Okay, and then this one, we're missing some initialization on that. So I have to go look at what that is. Yeah, what the, why do that? That's just so weird. All right, dynamic rendering equals true. Yeah, what's the other one? Most likely those are going to be out of order. Yeah, and the same deal here. Because C++ is dumb and assumes that things have to be ordered instead of just doing that for you. Oh, these have to be commas. Missing initializer for member, robust image access, inline uniform. Man, there's a whole bunch of random shit you have to set. That's probably the biggest reason not to do that. Also, let's see, long unsigned int. Most likely that actually I think I can fix. Is the GLM stuff? Is it engine? It's like either a vec 4 or a map 4. Right, does anything using this? How much experience do you have with graphics APIs overall before? I've been working on a game for a while. So, and kind of hand coded all my own graphics. And just used basically just SFML, SDL2, but not much. And then I went through the first part of learnopengl.com and realized that OpenGL is hot dog shit. I fucking hate OpenGL. It's a lot of just mysterious activity from a distance, and decided that was not for me. So now I'm trying Vulkan, and so far it's okay. I mean, it's a little wordy, but the thing that I like better is that everything is actually structured. It's a modern API, right? So it's like, it assumes you have threads, which means you have to have context and state. You have to pass variables to functions. It's much more object-oriented like. So, you know, the first parameter is the thing you're working on instead of randomly the first or the last. Things like that. But it is quite a lot of bullshit. Yeah, honestly, I've got no idea why. Okay, we're going to back this out. So one of the problems is that the initialization of a lot of these structs, it's just, yeah, it's not good, man. It's like, for some reason, like, he's doing that. I don't get it. Like, why do that and then all this? Why not do this? Initialize everything to 0. And then do that. Yeah, it's a very weird pattern. I'm not quite sure why. Because then it causes all sorts of warnings that you're not initializing everything. Alright, so we're going to go through and clean all that up. Yeah, here it's done like that. Then at the same time, yeah, when they created these structures, they didn't set any defaults under the stupid idea that uninitialized variables are faster, and they're not. It's caused bugs. You gave me a Go years back with this unsigned and signed. Oh my god, C++ was really much. Oh, yeah. Wait, you gave me Go years back? You made me... Oh, made you go years back. Yeah. I don't mind, like, if I kind of want, like, either I convert everything manually and there's no implied conversion, or your implied conversion is absolutely perfect, and they never are, right? Okay, let's see if that gets us somewhere. Yeah, I gotta think about how they're doing this crap. Yeah, see, missing initializer. Alright, we're gonna fix this all up. Hey, Wusa, how you doing? Right, and that just really irritates me. That's a bug in GLM. Is there some place I don't think I'm using GLM. There's somewhere where storage is getting configured to the length type is an int, and you can't use a length type. Why have an arbitrary length type? Because it always has to be a size T if you're doing this kind of indexing. Anyways, I'm going to have to figure out how to turn that off, because it'll just bother me. Yeah, okay, so you can't do this. There's just so many, it seems like there's so many, like, they're using structs as kind of an options. right? And then they don't set them to defaults. So you can't do it that way. Maybe there's some fancy C++ thing I could do, but and what we should do is make sure that gets set to zeros. And then that. Right, we'll find a way to also disable these errors in GLM. I'm also kind of curious why this error is suddenly showing up. I think maybe I just don't have this kind of setup. Remember VK surf color space. And how many others? Let's see if that does anything. I mean, that's effectively what it's doing, but let's go ahead and do this. We'll stick to there. Oh, wait, hold up. Wait, this is C++. Hold on. I should be able to just do that. Not sure why I would do that, but let's just see. Yeah, I wonder how many other places that's happening. Let's just look here. Okay. Okay, so you do have to pass that. Yeah, if they had set their headers up so that everything had default values, then you could really easily just sort of like pass these in with only what you needed setting. Because you're using these as like configuration variables. So maybe at the time I figured out how to turn off specific warnings. Honestly, all these compilers should have config files, but That's gonna be an enum. Yeah, see, it's just kind of annoying. It's really interesting because like it's a small little change that would make, yeah, just give everything default values, right? And then people can pass them in very easily with like configs. Right, and then again, size t. Not sure why dude is using an integer. Not sure why that song is so damn loud. And then we gotta tell GLM to shut up. Yeah, again, another size t. It's being used as an index, so don't do that. Okay, so then the only thing we gotta do is disable warnings in the Mason file. Let's make sure this still runs. Yep, good. Then we're going to look at Mason. Okay, GLM. Okay, we'll have to look at GLM and find out how to okay, we want to disable warnings. Huh. Okay, probably GLM quiet. No, that just prints out mirror messages. Okay, so we want to force it to do... Well, let's see if this is the default. Okay. Alright, so we'll have to do some custom options. Alright. Let's toss that there real quick. Get this. Yeah. I honestly don't know why they do it this way. It's really dumb. Like, it should be like I do this. And then I pass my CMake options. I don't know why I have to go through this convoluted... Yeah. I guess we're going to have to do GLM ops equals CMake. Subproject options. GLM ops add defines right. We'll see if that does what we want, and then GLM project equals A lot of crap. Alright, alright. So that'll get us GLM configured for just that. Alright. Let's see if it redoes it correctly. It does not. Alright, gotta reset. Wonderful. Alright, so we're going to see if we just disable that annoying error in GLM. And then we'll move on to the next part of the tutorial, which is, I guess, cleaning up the draw function. Draw function was pretty involved. I could see a few ways to improve it, but I think probably what I want to do is go through VK Guide, kind of get it all working. And then maybe take some time to kind of recreate it from memory, sort of. Alright, so let's try options until that shuts up. Nope. Yeah, why would you release a library that has that? Like, it's actually really bad. Because they're assuming an integer. Yeah. You just can't eat at everybody's house. Okay, so I gotta look at the CMake for that. Alright, we're forcing that. That's off, okay. What does this do? No. Alright, well, so we'll have to look into how to pass to the thing. Alright. Either I put up with it and I'm annoyed forever, or let me see. Let's say we're going to do GCC disable warning. -W, no. Okay. Let's look at that error message. Alright, we want to pass this. Not sure exactly how to do that. Right, well, let's just record it for now. I don't think this is going to work. No, that's not going to be right. But let's just get it down and then we'll figure out how we tell it to do that. Yeah, that's real stupid. Yeah, we'll have to go look at the CMake object. Okay, let's try it here. No. No, yeah, that's not it. Okay. Right. Mason CMake object. Append compile args. I think that's it. Okay. Why am I saying the language? I'm guessing it's C++. CPP? I don't know. I don't know what that can be. Okay, so if that does it. I don't know. Who knows what language is supposed to be called? It's a dictionary? Oh my god. No, it's not. Yeah, no, they're wrong. But I think GLM isn't. Yeah, no, because this isn't an include file with a template. I'd have to disable that in my own project. Yeah, this is all completely pointless. Alright, since it's just annoying the shit out of me, I'm just gonna do, Alright, we'll just, since this project, GLM, they don't know how to code, so they have weird sign conversion errors in their template formats. And then also this guy likes to use integers instead of size t for indexing into arrays. It's always just like a pro move. So we're just going to disable sign conversions for the whole thing. That way you can just move on. Booter's kit. That is the actual sound of my keyboard. Yeah. I can explain how I do it. So I have give me a second. So I have this thing called a piezo mic. I'll show you the one I got actually. This guy, one of these. They normally attach to a guitar. Like if you hate your guitar, you stick it to the guitar with the sticky thing. For acoustic guitars, and what they do is they're old, kind of the original microphones. They just translate vibration into sound. So I stick one of those to my keyboard. Here, I'll just tap it. So that's just me tapping it with my finger. So then what you hear isn't the click of the keys through the air, because that would just sound like just me mashing on the keyboard. Instead, it's each click vibrating the keyboard chassis. So if I tap the chassis, you don't really hear much. But if I click the key, you hear basically everything inside the key. That's one of the reasons why it sounds so nice, is there's no, it's not like in the air, which is just kind of annoying. Okay, we need to add this. I don't like it added there. Okay, let's just find CPP args. Yeah, we'll just do that. Really irritating. Alright, there we go. We're not going to get any sign conversion errors, which can be pretty bad, but if I could turn it off for one single file with the Pragma, I would, but anyways, alright, we'll just move on, because the main code has a lot of that too, from the tutorial. Seems to be a general weirdness. And we're enabling C++ 20 as our default, but we're doing 23, so that's fine. Okay, one more cleanup move. We'll do a full reset. And then onto the tutorial. So the real sound amplified to the microphone. Yeah, but the real sound from the keyboard vibrations and the internal mechanics. It's basically like a stethoscope. Like for listening to someone's heart. That's right on that keyboard. Alright, cool. And confirm it still works. And we're golden. Alright. Let me commit that. All right. All right, everybody, that should be in the Git repository. And we're in the engine, I believe. Okay, let's load the tutorial. Okay, so we went through all this. All right, improving the render loop. Before we can begin drawing, we have to implement a couple other things. First, we have a deletion queue that will allow us to safely handle the cleanup of a growing amount of objects. And then we will change the render loop to draw into a non-swap chain image, then copy it to the swap chain. Okay, all right. We could keep adding more things to clean up, but that'd not scale and be very annoying to keep synced correctly. We're going to add a new structure to the engine called the deletion queue. This is a common approach by a lot of engines where we add objects we want to delete in some queue. Then run that queue to delete all the objects. It's a command pattern. Okay, we're going to keep it simple. We have to store standard function callbacks and a deck. Alright, pretty easy. Deletion queue. Where would you exist? Is it in... Alright, we'll put it here until we're told otherwise. To execute all the functions, why go reverse? It's a stack. It's just a stack. All right, we'll go with it, but that's super weird. You chose the wrong data structure. Right? Am I just wrong on that? Yeah, you have a queue. You push back on the queue. Right? Hold up. Yeah, you push back on the queue. And then you go here. That means it's first in, first out, which is a stack. So just use a stack. Anyway, doesn't matter. Okay. Why is this freaking out? Yeah, why is this not? Oh, wait. What? How did you get up there? Hold on. I had a Vim accident. Alright, so that's the flush function. Wait. What the hell did I do? I pasted like a whole chunk of code and... Wow, okay, alright. Failing big time on my typing skills. What the fuck is going on? Alright, stop it. Okay, forward. Start at the begin, go to the end, and call the function. Okay, simple enough. Let's confirm that compiles. Hey Caesar boy, how you doing? Is the idea to adapt your roguelike to use Vulkan? No, I'm just curious about Vulkan. Yeah, no, just because I was going through OpenGL, and I'll just say, as a professional programmer, OpenGL is really poorly designed. Like, It's really weird. I don't know why programmers get into, like, I don't know, it's super strange. Like there's always something that is like obviously a fatal flaw of a technology, but they really like it. And so then, like, it's really obviously that's a bad idea, but they get really bought into it. So with OpenGL, it was the idea that there's sort of like a global state machine inside the library and you code it. Now we realize, even when it came out, we knew that was a bad idea, right? Just you're never going to be able to do threads with that. We just don't do that anymore, right? It's just not done. But for some reason, people love that. And me, I'm going through and I'm like, this is weird. Like some functions do this, some functions do that. Things get configured just sort of like magically behind the scenes because you called them in the right order, which to me is just like death. Like if I got to call stuff in the right order, that's totally how you screw things up, right? Throw in threads and it's just completely boned, right? So then I thought, all right, well, if everyone said OpenGL is great and Vulkan is way harder, let's try Vulkan. And now I'm going through Vulkan. I'm like, yeah, Vulkan's harder because you have to do more, but it's way more logically structured. Like the structure is much more logical. They could have made it a lot better. I think they could have really simplified a lot of things, but the structure of it is way more logical. Like you get a device and you get a virtual device and then you get a surface and then you swap the surface and you put the commands on the surface. You create a transaction for every command. Ta-da! That's it, right? It's basically turning the GPU into a web server, or I would say a database server, right? That's kind of what it's doing, right? Yeah, so it's mostly just for my own understanding of why people liked OpenGL and why Vulkan's considered difficult. And so my take so far is Vulkan is considered difficult by graphics people because they have been using an API that was not modern and designed kind of weirdly back in the day. And Vulkan is kind of a modern API that's giving you have to work it like a transactional database. It's kind of like my big first impression. Web GPL versus Web GPU? Possibly. That might actually be. We have an ad starting soon, everybody. 3 minutes. I'm just going to keep on coding, but that could possibly be. Maybe the difference is Web GPU is kind of more like Vulkan. But if you think about it, if you want thread safety, right? Like, okay, look. So if I do update person set age equal to 30, right? Okay. Hold on. Where ID equals that. Okay, so let's say I'm doing like some SQL like this, right? I'm doing some SQL. And then I want to do update person set name. You would never do this. You do it in one call, right? Okay, so if I was doing that, back in the day, we just did that with the database, right? So with the database, we would just, if we had to do 7 things, we could even have it, let's make it a little more realistic. So person pet, set person ID equals 1200, pet ID equals 900. Okay, so let's say I'm increasing a person's age, setting their age to 30, and then giving them a pet, right? So back in the day when things were all desktop apps and you didn't really have to worry about transactions or anything, like things basically worked all the time because it wasn't necessarily over the internet. Yeah, you could do this and get away with it 99.999% of the time. And in a few cases where it failed, people just go fix the database manually, right? But then we started doing internet and big databases. So then we had to start doing begin and commit, right? So you'd have these begin and commit ends. I'm probably getting the syntax on that wrong. Okay. But then it started to get to where like we would have a web server. So let's do SQLite3 named transactions. So we can do begin immediate transaction. That's what it is. And then, okay, so this is way more complicated. We have to do a begin transaction. We have to say whether it's deferred, immediate, or exclusive sometimes. We can use the keyword end if we want, you know, it's way more complex, right? But what it does is it guarantees, and then also the code that does this has to handle the instance where the transaction, when you do commit, doesn't actually commit and you get an error. So you have to go and clean up all the data, try it again. There's all sorts of things you have to do now, right? But it's because we figured out, well, you can't have like a couple 100,000 people on like a website updating database records, because you'd have one action would happen here and then it would go to another connection and would change another part. You have to have transactions in order to kind of organize the data, right? And so this is what I think happened is OpenGL was just this, where you go, oh yeah, I just create a thing and I put thing in there and blah, blah, blah. And I worked the state machine, right? And it's kind of old school SQL where we didn't really have the internet and threads and stuff like that. And Vulkan is this, where now you have to like, and it's even similar where like back in the day, you would just say the database. Now we have to say, oh, we got to connect to this shard or that shard. We have to do this part of the cluster. We have to do the master replication, right? Way more complicated. But the result is we get way more scalability. We get way better transactional APIs. We get more stability. We get like all sorts of extra stuff. We use databases for things that weren't intended. So this is what I see Vulkan as. Vulkan is basically the difference between someone running a database locally on their computer versus someone running a 6 PostgreSQL server cluster and having to do begin end transactions and handle all the things. That's Vulkan. So it could be the same thing. WebGPU was like Vulkan, WebGL is like OpenGL. And then also I think the other thing is like, I really think OpenGL just was like, just flawed from the beginning, right? So that's what I'm talking about when it's like, oh, you're working the state machine. But even in that, there's not enough information in the function calls to tell you what the fuck is happening, right? It's just sort of like tangential. You just have to know that if you have a buffer that you just touched, and then you touch these other buffers, they'll get connected. You don't explicitly say connect this buffer to that buffer. You just kind of work two buffers and magically they get connected. And my brain is like, yeah, fuck that. Like, there's no way that's reliable, you know? And I think the only reason they've been getting away with it is because, you know, for a real long time, games didn't really do like a lot on the threads, right? You'd have like a render thread that did most of the graphics, maybe a few other threads, right? And now, like, I can totally see, one, if you're writing a game and you got to load like a shitload of assets, having to do everything linearly is probably a pain in the ass, right? But then on the other side, GPUs became, I mean, all the money in GPUs now is not games, it's other things. So Vulkan is like the API of, hey, I gotta access a special NVIDIA $10 million machine with 100 GPUs, and I gotta basically run a massive LLM model on them. So Vulkan it is, right? Yeah, so that's just my initial kind of, like, from playing with from the two, I'm like, I don't know. Vulkan's annoying. It's got a lot of crap in it, but I kind of prefer it because it's structured and I can kind of read the code and know what it's doing. Like, for example, let's go cleanup. Destroy command pool on the device. These are the command pools to destroy. Destroy the fence on the device. That's the fence to destroy. Destroy the semaphore on the device. That's the semaphore to destroy. I can read this and I know what it's doing. OpenGL is like, add a buffer. Which one? The one you were just using? Like, what do you mean? But can I tell you the number for that buffer? No, it's okay. I got it. It's like all over the place. So anyways, yeah. Okay, so let's confirm the deletion queue compiles. I believe that's in the wrong spot. Standard function starts at lambda. Okay, anyway. Okay, so then that means in here, in our frame data, this is getting pretty thick. And then in Vulkan engine, so graphics queue, I'm not sure where he wants that placed. This is also getting pretty thick, so let's put it in here. I'm also kind of curious. You know, let's do a little bit of hacking. Let's do a little bit of messing with this. Modern OpenGL has DSA. So you can yeah, someone's mentioning like 4.5. I think RCR said in 4.5. But see, this is what I was talking about. Like when OpenGL 2 was being made, they should have said, okay, this internal state bullshit needs to go, and they should have just done it that way. But I think programmers get really attached to kind of weird, bad ideas. React is a really good example of that. User interfaces are not immutable. The whole idea of immutable state is just complete bullshit. Like, the point of a user interface is that it has a state that changes. And so a lot of the complications in React come from that weird idea. And it's obviously a weird idea, but man, do they love that shit. They think it adds all kinds of weird stability that isn't there, right? Another one would be static single assignment in Erlang. It's completely pointless. There's no reason to have it. But they made it seem like that's why Erlang was stable. When really it was stable because the Beam is a really great virtual machine for that kind of activity. But I don't know. Programmers love the one true thing, I guess. All right, I'm going to do something. Let's make sure this compiles still. I'm going to do something funky. I want to see something. Let's do... Let's put this on a heap. I'm kind of curious. Actually, what am I doing? I should use auto, which is just kind of one of the reasons auto exists. Just for fun. Let's see what we get. Yeah, the overloaded terminology in OpenGL has always annoyed the hell out of me. Yeah, it really is. C++ is the same? Yeah. I mean, you know, to C++'s credit, they try to fix it, but yeah, they get some really stupid ideas sometimes. And then they think it's the one true way. And okay, cool. Yeah, we can put it on the heap, no problem. We'll see if that causes problems later. Yeah, I don't know if you ever like find yourself fascinated by this one feature, this one thing, yeah, take a step back and look and go, is this actually a good idea, or am I just into it because it's being pitched as like the one true solution to something that I'm curious about or hate or something. Okay, so this draw function is gnarly, but we'll see what he's going to do with the current thing. All right, so whole function for every object we delete, which is not going to be optimal. Okay, so yeah, I was wondering about that too. I wonder how you would do that pretty efficiently. Okay, so we have to wait for fences. VK wait for fences. So right here, we wait for the fences. Yeah, get current frame. Interesting. Okay. And then Vulkan engine cleanup. Let's clean up. Wait for idle to supply to frames right here. I really feel like there's another way to do that. Okay, and then we have the main deletion queue right here. All right, flush that, delete. All right. Okay, cool. So far, so good. All right, and let's think about some new music. This music a little too, we haven't done in a while. And it's kind of appropriate. We haven't done the 80s. Let's do a 80s synth pop style. There we go. That's better. Okay, so we have a delete queue. To improve the render loop, we will need to allocate an image. And this gets us into how to allocate objects in Vulkan. Using Vulkan memory allocator library. Okay. Dealing with the different memory heaps and object restrictions such as image alignment is very error prone. Alright. Using VMA, we skip all that and get a battle tested way that is guaranteed to work. There are cases like PCS-X3 emulator project where they replaced their attempted allocation VMA and won a 20% extra frame rate. Oh, okay, interesting. Okay. Okay, we didn't include it there. Let's confirm VK types. Yeah. He has it here. VMA holds both the normal header and the implementation. Okay, so that's what he's doing. All right. So inside here, I'm assuming right here. Include, and he's using quotes. Okay, and then in the Vulkan engine, add the allocator to the VM Vulkan engine class. Whereabouts. Frame data. guess in a way it doesn't matter. Allocator. There. Now init Vulkan. Okay, well let me get that to compile first. Alright. I think it's time. I've been annoyed by this damn error forever. This time it dies. I'm actually going to go through and add that to every project. I hate that error. I kept it around because it kind of seemed like a good idea, but it's time. I'm just really annoyed by it. It doesn't really help. May do a clean reset. Just to be sure. Alrighty. Okay, so that's configured. Then we need to do the next part. And init Vulkan. Whereabouts? Where do we do this? Anywhere? Alright, so it's using chosen GPU. Must be at the end, I bet. You know what I think the author should have done is, let's say you have your init function, just to kind of get a sample. What he should have said is he should have said to do initialize the memory, to do configure devices, to do, right? Done a bunch of these comments, and then in the pros in the book, you see to do this. So you know what you're going to actually implement. So he has you copy paste these into the empty function, and then you know what you're going to make. And then you just kind of fill in the blanks as you go through, right? Because one kind of flaw is that I have no idea where half this code goes. BMA allocator create info. Yeah, so this is at the very end. Huh. Let's just try an experiment. See if it'll let us do that. What are you doing? I disabled that. Wait, what? Why is it doing that? Right, let's do, what are we doing? Mason build. I got a new weird error, no unused function? When has that been an error? No missing field. And also unused variable. Wow, man. Okay, cool. And then it's just the order should be the last thing. Yep. Save, make, DK engine. Yeah, so these go out of order, but maybe we can find the order. Yeah, I'm just kind of curious if I'm not doing no unused error variable. Okay, yeah. It's easier just to do it the way that they're doing it. Wow, man. What are these warnings, man? How many of these unused but set variable? Okay, so that's for me. Okay, what's the other one? Some error about type conversions? Seriously? Oh, wow, man. This is kind of like every once in a while you see those videos on TikTok where someone takes the top to their toilet, the toilet seat, and put it in their dishwasher. You're like, you live like this? You have the ability to turn warnings on, and you don't? So now we're in here. No conversion. Does it get this thing to compile? Okay, that leaves me one error message. Okay, variable not used. That's fine. Okay, and then we do the next part. Okay. Success. Right, so that's to get memory management. Yeah, kind of curious about that. Let's use GPA pointers later when we need them. Okay, now the new draw loop. And let me boost this font so y'all can see it. Drawing directly in the swap chain is fine for many projects. It can even be optimal in some cases, such as phones. Okay, interesting. But it comes with a few restrictions. The most important of them is that the formats of the image used in the swap chain are not guaranteed. Different OS drivers, winning modes have different optimal swap chains. Right, so HDR, things like that. Okay, one very important limitation is that the resolution is fixed to whatever your window size is. If you want to have higher or lower than, and then do some scaling logic, you need to draw a different image. Swap change formats are, for the most part, low precision. Rendering have high precision formats, but you will often default to 8 bits per color. So if you want high precision light calculations systems, that would prevent banding, or to be able to go past 1.0 on the normalized color range, you need a separate image. Okay. The whole tutorial rendering into a separate image than the one from the swap chain. After we're done with the drawing, we then copy that image into the swap chain and present it to the screen. Okay, so you tell the GPU to render into an image. Yeah, just double buffering, right? We'll be using, the image we will be using is going to be RGBA 16-bit float format. Oh, interesting. Slightly overkill, but will provide us a lot of extra precision that will come in handy when doing light calculations and better rendering. Okay. We've already dealt superficially with, get some tea. We've already dealt superficially with image, but that was handled by VK Bootstrap. So now we're going to do it ourselves. Oh boy. This looks like a big project. Oh, I think I'm going to sit down. I got to sit down for this one. Got to put our professional coder pants on. Nightbird, I feel so bad and confused right now. Oh, that sucks, man. The same my job. I usually do microservices using Docker and backends. But Steak, I just said I need to write a script to convert 8th wall projects to our formats. 8th wall? Never heard of that. Don't even know how to say no to this tax. You just say no. It's not that hard. But I don't know. You're saying there's no information on this 8th wall? I never heard of it, by the way, but you can't like contact them and say, hey, we need to convert your stuff. And also like finding out where this comes from. They might be saying we have to convert 8th wall, but actually it's a completely separate problem they have. I would dig deeper. Like if this is a format that's difficult to get at or convert, just start asking around like, okay, why do we need this? What are we trying to do? You know, you might find out they want something totally different. Okay. All right, so in types, we're going to need some new stuff. Oh, that's a lot of info. All right. All right, and then in VK engine, I guess put it here. Right, confirm that works. Okay. Then we need in VK initializers. I'm surprised no one has gone to the trouble of making this all go away. I think NVIDIA has a library that kind of does that. Like the fast, no one ever tried this. Must mean something, fact. Well, I mean, you can just say I'm not really able to do it. You can find somebody else. I mean, you're allowed to say no, man. So, like, I don't think I can do that. I think you have to find someone else. Okay, that's very nice of you, web browser. Alright, I think I'm gonna have to grab this line and just copy it. So I can't find the scroll that I need. Okay, extent and flags. I feel like that should just be a constructor. Yeah, it's kind of weird. Like a lot of times. Okay. Okay. Let's see what this is. Where I'm at, it's hard to switch jobs. I'm scared to lose the current one. Do you actually think he's going to fire you because you say you can't do this crazy thing he wants you to do? If that's true, then go ahead and do it, but just remember he did that, and then when you have the power, make sure you gouge the shit out of him. Where is this? There's the slider. There we go. I think programmers don't do that, man. Like they go, I'm worried I'll get fired. I can't say no. Then when we have the power, we're just like, I'll just take any pay I can. Dude, when you have the power, because the market's hot for programming, then you need to be in there just getting the most bank you can. Telling them no every chance you get. Making sure you change the way the industry works for the next one. Instead of constantly assuming that you're gonna get fired if you disagree. If you think you're gonna get fired because the market sucks right now, okay, that's legit. But then if you just roll over and take it whenever the market is good, you're not really understanding the market. If you're basing your decisions on market behavior, then when the market's good and he can't afford to lose you, that's when you gain control, get your pay up, do everything you possibly can. And whenever those people who threatened to fire you when the market was bad say something, you go, well, the market's really good now. Remember when you were going to fire me because you thought the market was really bad and I couldn't get a new job? Well, now the market's good. So that's capitalism. Yeah, I don't know why we do that. Like, no, I don't think so, but I'm scared there'll be more crazy, innovative ideas. And it sounds like somebody needs to tell him no. Like, standing up for yourself is always something you should do, right? And here's another question. Have you been searching for any other jobs? I thought you had this job with the university. What happened to that? You need some art? Okay, cool. Yeah, we can queue that up. Yeah, so like if it's this bad, if you're so afraid of saying no that you're worried about you getting fired and everything that they ask you to do is because this crazy dude discovered vibe coding, then you should be dropping your resume on every company with a pulse trying to find a job. Or trying to start your own thing, or trying to do everything you can. And then, once you get your job, you're going to start in 2 weeks. You tell that dude exactly what you think. And you say, you know what? I'm quitting because you keep telling people to do shit, thinking that vibe coding solves things. It doesn't. I'm quitting because you keep doing vibe coding because you did this idea, and you forced me to do it, and I'm quitting tomorrow. That's it. Extra documents require more time. Yep. Well, that should be your top #1 priority, man. Like, I think you do not enjoy working at this place. So for your own mental health, you got to get the hell out. You have 2 choices. Either you stand up to this guy and you say, no, I'm not going to do that. That's fucking stupid. And if we need to do it, we're going to do it right instead of vibe coding, because us programmers are the ones that pay for it, not you, dumbass. I mean, you don't have to call them dumbass, but right? Or you have to go, okay, that's cool. I'll work on that. Don't work on it. Try to find a job. Just kind of pretend like you're working on it. Go get yourself another job. And then when you get that new job, try to confirm that you're not going to get fired if you tell somebody no, which is actually really rare. A lot of places do that. It's not unique to where you're at. It's actually a really common abusive thing. Like, I mean, remember, I've had interactions with people who say that I won't get a job because I put underscores in variables. You're never going to work on an open source project or get a job if you have an underscore in a variable. Like, oh my God, I would never want to work there. What makes you think I want to work at anti_.com? And I kind of always think we should make a list. Kind of like a reverse disqualifier list, right? Hey Xantes, how you doing? I even told him I enjoy AI assisted learning and hate no thoughts brain vibe coding. Yeah, I mean, I think probably the easiest way to put it to him is this. When the work is done, who has to fix its bugs and who's responsible for the outcome? It's not him, it's you. So you just say, I'm responsible for the outcome. Therefore, I'm going to control how I do it. That's it. Now, if you want me to use vibe coding, then that means you're the one fixing all the bugs and you're the one responsible when it fails. He'll never agree to that, right? Get him to put it in writing. If you use vibe coding and there's any bugs or any problems or any defaults, I hereby say that you are not responsible for any of the results. I will be the one who takes the hit. It'll never work. He'll constantly try to weasel out of it because that's how those guys work. But the second you do that, he'll be like, oh, well, man, I don't want to be responsible for the results. I mean, you're the programmer. And go, okay, if I'm responsible, then I'm the one in control of how I do it. It feels like Zed said, you're really are not responsible. Yeah. And then you just get that up front, man. Like, because I know how those weasels worked. I worked for many people like that. I worked for a dude once who sent emails to everybody demanding that we do a certain thing. I kept telling him it would fail. This is terrible. This is not the way to do it. I kept telling him over and over again, no, you can't do it that way. So we did it anyways. It failed. Then he had a big old meeting where he was blaming us. And I said, you sent us multiple emails telling us to do this. He's like, I never sent any emails. I knew he would say that because he does that all the time. So I printed them out and literally printed them and shoved them across the table as here they are. He's like, I never wrote these. He doesn't even look at them. He's like, I never wrote these. I'm like, yes, you did. And I handed them to other people. And he's like, no, I didn't write those. I didn't write those at all. Everyone else was reading them and they're kind of like, okay, well, I think we don't need to do this meeting anymore. And they left, right? But you know how insane you have to be to like literally deny to everyone's face that you didn't do something when the printed fucking thing is in front of you? Like how crazy those guys are. They'll never take responsibility for what they do. Ever. Vibe coding is faster Stack Overflow without the snarky insults. Yeah. I think that's pretty right. I mean, even like, yeah, and even like the end result, you know, Stack Overflow is not bad, but it is definitely full of a bunch of people who kind of know more than they're capable of, right? Drum original. Sadly, the tech industry is infested with parasites. It is, right? But we don't do anything to shut them down, right? Let's take, for example, my idea. What if there was a website? Say you're working somewhere and they are threatening, you work for a manager and he's threatening to fire people if they put an underscore in their variable names, right? Classic Go thing. Or I've heard people say that if you don't have const on every single thing in a C++ project, they're going to fire you, right? Okay. So what if we get those reports, get the emails, we pack them up, dude just got fired. He goes, yeah, I got fired because I didn't put an underscore. Or you find someone on Reddit, they're like, well, I'm going to guarantee that you never find a job if you disagree with this stupid underscore policy. Right? Okay, you find that dude. So what we do, we record the email, record the company. The company gets put on a blacklist. The tagline on the website is literally, when the economy is good, you're fucked. We will literally get every programmer we possibly can to sign, we are not going to work for any company listed on the disqualifier list because they're trying to disqualify people for dumb shit like disagreeing in a Reddit thread or not wanting to use underscores, right? Okay, make a big ass list. Economy swings the other direction. Those companies are desperate to hire people. And watch them just come crawling, begging to get off the list. And just say, look, you had a chance to fire the dude who was firing people over underscores. Now here's the thing. I guarantee for every shithead little manager at these companies who's firing people over underscores, there's someone above them or above them that really, really understands that if this gets out, they're never going to be able to hire anybody, right? And so they will quickly shut that shit down and fire that person immediately and prevent that from happening, right? Because if you have a website where you're just outing, yeah, my manager literally is telling me that I have to vibe code this up, and if I refuse to vibe code it, I'm fired. So I just told him no, so he fired me. Go, cool, on the disqualifier list. So then say it's Facebook or something. So then a manager above that guy is like, wait, how do we get on the disqualifier list? Holy shit. Who's the one telling people that they're fired if they don't have an underscore or they don't use this AI tool? Okay, bring that person in my office immediately. You know it had happened because the number one thing that all these companies that are firing people right now, they know that's temporary. When the economy is in a boom, they're going to need to hire people. If they're on a list of companies that treat people like shit and fire them over underscores, they're screwed. Like hiring in the tech industry is one of the top things every company worries about. They're constantly worrying about that. So anything where they're exposed is like some shitty company that's firing motherfuckers over underscores, they will shut that down immediately. Right? We won't do that, right? We'll take the hit. We'll argue with some middle manager in Reddit and he'll be like, I'm going to make sure you never work in this industry again. with his like pathetic little position at Oracle or something like that. Wouldn't it be great to fire back and go, cool, bro, I just put your comment on disqualified. And yeah, your company, as soon as the economy gets better, your company's never going to hire another motherfucker again. Right? But no, it'll never happen because programmers are too worried. Oh, but if I submit that, I'll never get a job again. All right. So then we just keep putting up with it. Why can't the manager vibe code it if it's so easy? Exactly. Just be like, okay, well, I'll help you do it. But if it's broken, you have to fix it. Or why don't you do it? You know, in Russian, but actually I work in an American company and they pay Russians much less than the others, requiring more. Makes you angry. Like, I'm fine with it. Yeah, man, I'm telling you, you need to change jobs. You need to, yeah, you just need to. No. Feel free to come and tell me about this is the kind of like bullshit politics and rage baiting and shit like that. No, I'm not into that crap on this stream, right? But programmers in the industry, the fact that we have to deal with, like, we have one of the most stressful white collar jobs ever. Like, so many programmers, 80 to 90% of programmers report that they have zero control over their job and that they're stressed at work for a job that is actually kind of fun and pretty straightforward, right? And it's all because of these kinds of management decisions, and the people in charge generally are not programmers, right? So if you want to change it, people got to talk about it. Instead, we kind of keep it this dirty little secret, you know? Or when they get in positions of powers, those same programmers turn around and go, well, now you're fired over your underscore, bro. Like, no, fuck that. We need to stand up and say, like, yeah, you can't fire people for not formatting code the way you think it should be. Or because they decided to name a function a different way, or didn't want to use your stupid text editor, you know? This is an amazing career. The actual jobs are terrible. Yeah. Here, quick survey. You don't have to say it, but how many of you get raises? You know that we're one of the only jobs where you don't get consistent raises. The only way you get a raise as a programmer is to quit and get a new job. But they complain, programmers don't stick around. I'm like, well, how much of a raise did you get them? Well, the sales guys got a 30%, but the programmers got 1% or no raise. Like, that's why they leave. You have to give them a raise. I'd have to match the current market. They even was talking something about maybe we will sell the company next year, and they ignore the question about what will happen to the team and due to the political situation. Many companies will fire me. Yeah, no, it's true, man. You have to, you know, even in the US, you have to hop jobs. That's the only way you get more benefits, better pay, and better positions. You never get promoted. You never get raises. You never get like anything. Even though the company will typically make shitload of some money off your work, the only thing you get, usually as a programmer, is fired. The second the economy is bad, the quickest way for a company to make money is to shit can all the programmers. You see it over and over. They just fire tens, 20, 30, 40,000 programmers whenever they want to make money. Because programming and also like HR people and marketing people are like the easiest ones to fire, because if HR was doing its job, then firing a bunch of HR people, you can do it because you're not going to be doing any hiring during bad economy. Programmers are doing their job. All your systems will run on a skeleton crew, so you can just fire a whole bunch of programmers. And marketing, you can cut back your marketing budget and then cut a whole bunch of programmers, right? So yeah, so it's this kind of thing where like you put in all this loyalty, you do what you're told. Oh, I'm gonna make sure all my variables are camel K's and I have cost on everything, and I'm gonna be a good little programmer, do what I'm told. And then you're there for 3 years, and they go, oh, no raise, nothing like that. Oh shit, the economy's bad. You're fired. You're fired. You're fired. You're fired. So the only thing you get for your loyalty and your good behavior is shit canned without a raise and no benefits. So maybe just start taking that into account. You go get a new job, economy's good. Yeah, you're going to pay me about $500,000 a year because that's what I'm worth. And yeah, because I know you're going to fire me the second things go bad. So I got to make my money. Or if I turn 40, that's the other thing. I turn 40, I'm done. So hey, you got to pay me. I got to build up an alternative income source. And then honestly, if companies complain about that, they don't like it. Well, I mean, come on. The solution is like you're a capitalist. This is somebody you need to hire. Therefore, pay them. That's how capitalism works. You pay them for their time. You want to keep them, you pay them more for their time. And I should also just be really honest, like, for most of my career, I was exactly the same. I was like, oh, I got to do this. I don't want to get fired. I might not get another job. I totally understand. Like, I am also, or was also, a complete wimp when it came to standing up to managers and telling them no. It took me many years to sort of realize what kind of bullshit they pull, find ways to counter it, and shut it down. Like, for example, when I explained I printed emails because I knew that motherfucker would do that. He would claim he didn't send an email. So you just get used to covering your ass, CYA. Print out your emails because he's going to say he didn't send them, which is insane and should never be a thing, but that's what it is, you know. It is very hard to get a raise in any job, though, sadly. You should just leave and negotiate. I think that's a recent trend, but no. I know sales and marketing folks, they will constantly get raises. Every place I've worked, sales dudes are getting fat bank on commissions and raises. Marketing folks like developer relations, they're getting huge raises for meeting targets and stuff like that. HR people raises, well, obviously because they run the raises. And then every CEO, every manager raise 30%, 40% for meeting arbitrary positions, but then programmers, nothing. And that'd be fine if when you quit to go get a raise, it was like, oh, okay, well, yeah, we didn't give them a raise, all right, there they go. But then companies are like, oh, you're so disloyal. Why would you leave? Because the market's good and I want more money? Like, capitalism, bro. You can't have capitalism one way and then not another. Okay, so now, this is getting really complicated. Now, at the end of a knit swap chain, let's create it. Oh my God. This is so much. A knit swap chain. Okay. So are we getting rid of this? Interesting. I'm really curious to kind of redo this. Like, I'll go through and I'll learn it. It's always best to kind of, do as you're told, then go see if you can do it better, right? But I keep seeing all kinds of ways I could possibly do a little bit of templates. A couple little modern C++ things here. Can definitely relate to that. Let's see. It also keeps wages down. People get more desperate and you can rehire them for half the wage. Yeah, it definitely is true. And then also remember, the tech companies are consistently caught in wage theft scandals, right? Remember the big one? Like 2006 to 2015, I think? Or 2010? Or, all the main companies in Silicon Valley, we're talking like about 100 of them, led by Apple, all communicated with each other that they wouldn't hire from each other, which lowered the salaries. And somehow they got a slap on the wrist. They had to pay like $300 million to like all the programmers. So I think everyone just got like $10 or something, right? But it should have been like a company destroying thing, right? It should have been like Apple caught in that, should have destroyed Apple, right? Because it was like billions and billions of dollars stolen from programmers. And it just did nothing. We just kind of like, okay, I'll take my money. That was it. But the upside of that was the second that it was found out that Google was involved in it, there were like top programmers at Google that were like, yeah, I'm leaving. There was one person, the story was that Richard Schmid literally went to his office and begged him and then like handed him $4 million to stay. And he was just like, fuck you, I'm leaving. And then he handed him so much money that the guy finally stayed. It ended up forcing Google, at least, to pay their people well. And then also, interestingly, it turned out that Facebook was like the good actor in all of this. Facebook didn't get involved in any of it. They didn't do any of that wage theft shit. They were like the one company that didn't do that. Which begs the question, why didn't they tell everyone this was going on? Because that would have destroyed their competitors and been kind of awesome. Yeah, so anyways, if you think companies are your buddy, no, they're not. As long as you have big business in the White House, we will continue to get slapped on the wrist and screw their employees. Yeah, pretty much. Yeah. Or even like, not even the White House. Yeah, just as long as there's companies paying off senators too. Like, remember the big tax bullshit, Section 23 or 173 or whatever it was, where like it had lab technicians, chemists working on this, like specific jobs, and then just said programmer. They were all considered research and development, right? So like this dude fixing buttons on a website was doing research. Like what? All right, we've got another ad starting, and Squid requested some painting. So after the ad, we'll do some painting. Nuke. Why should the C, C++, OpenGL guy do web things? Well, I mean, you took the job, man. I will say, I don't want to, like, upset you, but I don't know. If you are a professional programmer, you should be able to do almost anything, right? Like, I would personally take it as a challenge to be like, okay, yeah, let's see if I can do it. But I would tell him to go fuck himself when it comes to the AI bullshit. Yeah, nothing bothers me more than companies that try to mandate tools. Yeah, I'm really surprised nobody made a library that makes this easier. This is all just seems like shit that could just be really common. Like, I don't think there's anything in here. Okay, I'm just going to copy. You know what? Yeah, this all makes sense. I'm just going to copy it. And then study it this way because it's kind of annoying. I'm a big proponent of typing all the code in, but when it's just this kind of like bullshit plumbing stuff, who cares? VK image create info, create image view, main deletion queue. Yeah, it seems to me like you could create a stock setup. Yeah, interesting. Hey, Asiller, how you doing? Alec. Yeah, doing good? Nice. Oh no, hold up. No, that's not right. Wow, that's a lot. Yeah, doing good, doing good. Just kind of getting the... What's the capture of this is deprecated. It's deprecated. Well, I don't care. I'm not... So you want me to list each thing? Okay. What? I don't think anyone actually wants this when you do equals. So I wonder why. Odd. Okay. Oh my god, man. Okay, let's take a painting break. We're gonna do some painting. Yeah, this is brain melting. This is so much stuff. Yeah, I really feel like you could do just like a couple of classes. I don't think you'd need much. And just simplify a lot of this with just sort of like the basic choices and a bit of template. Let people kind of like inject what they need. But a lot of this like memory management stuff, make a nice deletion queue. All these things, I think it can just be abstracted away. Yeah, I'm looking at this and it's like a pretty small library. I mean, so far. We can get you just like your basic setup stuff, initializing your things, and then you just basically start doing the drawing on your own. Yeah, interesting. Let's see, Scott. The new use I have found for AI is pseudo teacher, code checker for the course on Rust taught by Rust Rover. I'm trying it out and so far so good. Yeah, I think that works. Yeah, like you just have it say, can you find any flaws in this? Okay, we got this. Okay, let's take a painting break, man. This is the brain. Nuke, don't get me wrong, I did some basic JS too. Well, okay, well, here's the question. Is the problem that you just don't know JS well enough? Like, are you kind of, I don't want to say timid, but you're like, I don't know JS? Because the JS is gnarly, right? It's like an old language, but modern JS is pretty reasonable. You just avoid a few things, like if you use the new fat arrow lambda syntax and let and const, you get rid of a lot of problems. And then maybe like try out TypeScript. I think you might like TypeScript better. I find TypeScript annoying, but if you want the types and whatnot. When I do GPU stuff, I'm gonna try STL GPU. Yeah, there's also a thing by NVIDIA. I gotta find it. I had a note about it somewhere that apparently abstracts this away pretty well. It's cross-platform, so it runs on like DirectX or Vulkan and stuff. That might be the next thing I try. But I am kind of into conquering the beast, and then, but so far this is just a lot of plumbing. I can't really see, like, there's not a lot of graphics dev in this. It's just a bunch of plumbing. So we just finished this thing. Alright, so I don't know if we need to create swap chain anymore. Let's compile it and see if this runs. Alright, so far so good. It's a lot of moving parts, man. Okay, we create an extent 3D. Let's get a walk through this description. Then we need to fill our usage flags. Let's see. All images and buffers must fill a usage flags. Okay. Transfer source, destination bit, storage, color attachment. Okay. So we can copy from and into the image. Storage, because that's the compute shader can write to it, layout, and color to draw geometry into it. All right. Right, so this is the 16-bit floats. Where is that at? Is going to be, so this is 16-bit floats for all 4 channels. We use 64 bits per pixel. Holy crap. When we're creating the image itself, $64 bits per pixel. Wait, what's that come out to? I forget. 64 divided by 8, that's 8, right? Per pixel. $16. Yeah, 64 times pixel. So if you're doing a 1080p, 1920 times 1080. Oh, it's not too bad. 15 megabytes, right? Oh yeah, that's nothing. And the image itself, we need to send the image info and an alloc info to VMA. VMA will do the Vulkan create calls for us and directly give us the Vulkan image. The interesting thing in here is usage on the required memory flags. With VMA memory GPU only usage. There we go. We're letting VMA know that this is a GPU texture and won't ever be accessed from the CPU, which lets us put it into the GPU VRAM. Okay. To make sure of that, we are also setting VK memory property device local bit. So device local. All right. In Vulkan, there are multiple memory regions. We can allocate images and buffers. Right. The upload heap can be the entire GPU VRAM. Also be much smaller, generally 256 megabytes. We tell VMA to put it into GPU only, which will prioritize it being on the GPU VRAM, but outside the upload heap region. Interesting. Okay, so you can have like sort of like a communication channel in a way. You can have a place to just easily copy or just write directly to it from the CPU and then tell the GPU to copy it over, or hey, everything's just in the GPU, or you can say I need access from both. All right, so now we need a way to copy images. So add this. You can't copy images. Holy crap, man. God, every time I see this, I just think there's another way to rewrite this. Yeah, after we get it working, I think I'm going to go through and kind of see, like, is there just a way to do it differently? VK images. Alright, so this seems to be copy image to image. Aspect map, color. VK command, blit image to command. Okay, yeah, I think I'm going to type this one out. Okay, VK image blit 2. Okay, so we'll just copy this. Sure, that's exactly what I meant, Vim. Okay. Okay, we're gonna go. Okay, so then it's pretty much the same, but it's let's confirm those are color bit. Yeah. Okay, and then each of these yeah, man, it's a lot of configuring these structs. Yeah, if there's just an easier way to do that, right? That'd be so much better. That would get rid of a lot of this crap. Like it's almost that they just don't have proper constructors because it's a C project, right? Like if I was going to rework this, it'd be like... So that'd be easier if it was like that. But then they have all sorts of like additional things that get set, and they don't give them defaults. So because there's no reasonable defaults, you kind of have to set everything. Now, let me see if that compiles. I'm curious. Oh yeah, you talking about my tags? Oh, I haven't touched those in a while. Oh, let me... Give me a sec, I'm Annie. I didn't like your C++ code. Automod hates C++. It hates C++. Automod is a Rust programmer. What's this? Let's see. There is app bindings. I use them, but some don't like them. Yeah, I think I'm using some of it. Is it the VK bootstrap or boilerplate, whatever it is? And then you do like a builder thing, right? VK image, that's it. Yeah, I don't know. I just feel like a lot of this is just setting configs. Oh, did that compile? If that compiles, then this is stupid. That did compile. However, this is kind of more educational. But this should be the same order, so you can do aspect mask equals... No, this is base array layer. Yeah, the mistake that C++ made is requiring you to put these in the correct order. The compiler should figure that out. I find that to be just some of the most obnoxious bullshit I've ever seen. Because in C it figures it out. Like you can put them in any order, you can miss some. All the remaining ones get set to 0. So as a C API, I bet this is easier to work with. Man, it almost looks like a config file. It is, right? Like it's a config. Yeah, and see this? Error designator order field. See, that should not be an error. I should not have to go in there and get this shit in the right order, right? Like, you just figure it the fuck out. I'm telling you the exact names. This is the whole point of using the exact names, is I don't have to get the order right. I find that just to be the most weird. Like, was there just some lazy asshole on the C++ committee who's like, I don't want to look at the struct and help you? You know, so you just got the standard to do this? Because in C, you can totally do this. And it C's like struct initializations. Yeah, I'm going to make a bold statement. This is probably easier in C. Because you could just write code like this, right? Where you configure it instead of these like ultra complicated. Yeah, like this stuff makes me cry, right? Like this weird repeating this over and over again, bullshit. That should just not be a thing. It should be like this, but because C++ won't let you do them out of order, that means you're dipping into the header file. And then if the header file, if let's say there's like a few other things between here and here, right? So let's say there's like Y, then you can't leave gaps. It's real messed up. Like in Z, it's way better. In C, it's like so much better. So imagine when you do C, you probably do it like this. You say, like, honestly, you probably just like pass things to Vulkan with, like, I bet you anything, the design is func, and then dot thing, dot that. I bet this is the actual design for Vulkan. And the idea is you call functions with like little config structs as temporary variables like that. But in C++, that fails because you can't do things out of order. You have to do every single part of the struct. So like, yeah, and then we'd have to go look at this DSD sub-resource to confirm that what the order is, and like, who knows, right? Like, I think what's really stupid about it is this code works just fine. No complaints about doing it out of order. This code doesn't, and literally it's like they just translate it. They just do this in the compiler. They just do this. It's that. That's all they're doing. They can't even be bothered to just, okay, fine, we'll just like replace the code with that. You know what I mean? It's sort of like, if that's an error, right? Doing it out of order is an error, then it should also be an error when you do this, right? Yeah, very interesting. Okay, so we got that much done. Hey, Pranav, how you doing? Ultimus, blit. Asking why use a renderer if we can just blit an image to a buffer? Just mem copy. Yeah. I'll rewrite my my game to use Vulkan, but it does a raycaster to an image. so all we'll use Vulkan for is to just blit the image over. Hey Shaman, thank you for the subscribe. I appreciate it. Scared of burn-in on my OLED 32.9. Why do you have a 32.9 monitor? Can you even get one of those? What is a 32.9 monitor? It's 1440 tall and how much? 5120 wide? Okay, I'm gonna make a guess. I'm gonna make a guess, Mega Burger. You have a monitor. Hey, we gotta go over to Windows. I know. I'm gonna call out Mega Burger for something. Mega Burger, I demand the truth from you. Okay, so your monitor is shaped like this, basically, right? This is your monitor, right? 227s, yeah. So you do this, right? And then I bet you go to every website with your browser fully maxed out, and then you complain when the website does this. Am I right? You go to every, and then you email them, hey, on my 32.9 monitor, and your web, the content goes from the left to the right. It never occurs to you that you can just just do that. Am I right? No, you don't? Come on. I know you do. I know you do. I know you just come in and go, I'm going to browse the internet on my 32.9 monitor, and you're over here reading Facebook like this. I know you do it. Emailing people, your CSS is messed up on my 32.9 monitor. You have to do that. I know it. So effectively, you're reading the internet like... This is you reading the internet. You're like this. I actually have two monitors, so... This is you on the internet. It must be great for having tons of tabs open. As I'm going to give you a pro tip. I'm only teasing you so I can show you a pro tip. if you're on Windows, see how I'm doing this? Like moving them around. Okay, so if you hold down the Windows key and the arrows, you can actually move things from side to side, and then they'll also sync up with each other. So see how I have this one and this one? And then you can grab in between them, move it where you want. So it's like an automated, like a built-in tiling window manager. It's kind of the best one I've ever used. Most tiling window managers are super annoying. But the one built into Windows. Just hold down your Win key and use your arrows. This Hyperland feels weird. Exactly how Ubuntu. No, they get it wrong. I have to actually disable it. I don't remember what it is exactly, but this doesn't work right. I'm not sure. I don't remember what they do. But that part is really not done right. I can turn it on and try to figure out what it was that just pissed me off. But so you see how I can like slide this left or right? Oh, I remember what it is. Okay, so here, I can kind of give you a demo. Okay, so if I fire up Vim, right? Okay. So let's say I put Vim here, okay? Now I switch to my terminal. If I bring this over, Vim stays that size. On Ubuntu or those other ones, it resizes everything on the left to be this size. So it only has the concept of the screen is split in half and everything on the left gets to that size, which is just wrong. I didn't resize that. So if I do this, right, then when I switch to here, this is also expanded. It grabs all of them, which is wrong. I don't know what insane person thought that's what you want, but yeah. Yeah, so that's the thing. I had to disable it, so I manually slide them. Otherwise, it's pretty similar. There's one other thing I had to disable. I don't remember what it is. Another pro tip is wiping the toolbar at the bottom of the window screen from icons that are there. Then it is just ones you have open, and you can use Windows key to navigate between them. So you can do like 1, 2. I'm not sure what you mean. Yeah, not sure. On which OS? Actually, I can show you. Let me see if we can do it. Let's go to Linux. Is this Linux? Ubuntu. Let me see. All right, so right now I have it configured here. So see, I can do that. And I can do that. Now they're not connected, right? So if I grab one, it's separate. Okay, let me see if I can find the config option. Desktop. Multitasking? No, it's not that. Where the hell was that? I had to find it and kill it with fire. It needed to die very quickly. Figured dock behave. Enhanced tiling, tile groups. This is the one. Show a list of open apps to fill the empty space. Yeah, okay, so we do this. And that should do it. So now, let me see. I think. Yeah, so if I do that. Okay, now that's connected, and I believe, yeah, so they go together. And then I think the other ones behind it, there were a bunch of situations where when I would do that, now this one would get out of whack. Yeah, so if I take this. Oh yeah, this was another one. It's always doing that. Okay, so now, yeah, it was basically, it did that a bunch where like that one on the, they would get connected and you couldn't have them disconnected. So it's just easier to just disable that feature. So these are, well, actually I just upgraded. I wonder if they fixed it actually. That'd be fantastic if they did, because it's really freaking annoying. All right, let's shrink that. Hey, maybe they fixed it. Yeah, so what would happen before is it would, if I moved this, it would also move everything that was on the left side. So in my use case, I was doing this, right? Terminal was there. I would go like this, right? To kind of get my setup. And then I'd go to the browser. And the browser would be this big. It'd be in there. Like, what are you doing? I didn't want that. I was kind of harsh on Mint. Mint would be good if they enforced the tiling as a feature. You got to be strict with that stuff. I have the toolbar go invisible if I don't need it. Yeah, mine's, you mean the dock? Yeah, that goes away. Anyways, I actually don't need this. I need that. You know, it looks like they might have fixed it. I just upgraded the latest Ubuntu. It was definitely doing that thing where, like, before, if I had this here, it would also link that, and then I'd just be stuck with two things on either side, with completely useless. All right, I'll leave it like this. We'll see if we hit it again. Okay, we're currently getting this last part. Okay, image blit. Oh no, I remember now. It's this. It was that and also this. When I pick Vim, it flips this entire window. So I can't tile it like this. It considers this one whole window now. That's what I had to disable it for. Which is just stupid. So yeah, so see how I switched to here? I switched to here, right? Okay, now I want this to be here, and then no, it does that whole thing. It treats this like one whole window now. So I had to disable that. Yeah, that's what it is. Whereas when you go to Windows, it'll let you just kind of like switch back and forth between them. Yep, that was it. So then I had tile groups, I get rid of that, and then problem solved. Hey, Iron Imp. No, I haven't seen you in a while, man. Welcome. You like that? No, because I have to flip between the three, right? In this situation, it's not too bad, but what was happening was when it was shrunk off to the left, it was really annoying. Okay, anyways. We have to add this, oh my god, now, see what I mean? Oh, and that too, that needs to die, like, hard. Whoever thought I want to do that, you just, all of the punches right to your face, man. Never do I need a hot corner like that. I swear, man, the choices in our industry are powered by mental illness and childhood trauma. That's everything in the programming world is because of that. All right, blit info. Okay. Blit info. There's a lot of shit to type just to get a copy of an image. I'll get this right by just copying it. Not too hard to get that right. God damn it. Right, DST image equals destination image layout equals. Okay, I'll just grab that again. source image equals source. Source image layout equals image transfer optimal. In the back of my head, this is reminding me, I'd have to go confirm this, but there was an old competitor to TCP IP created by the phone companies. And I can't remember the name. It was like, I forget. But anyways, it died because it was like this. It was like really verbose and had the requirement that that destinations had to be notified 100% reliably that a connection was changed or closed, which just wasn't possible in the early days of the internet. Even now, it's not really possible. This reminds me of that. I'd have to go look, though. I could just be imagining things. Wouldn't it be wild if the same person who worked on that also worked on this? It's just going around making the same mistakes everywhere. Filter linear 1 blit region. Okay, so this is just a basic copy command. Anyway, with the above mention to what a blit is to audio synthesis code, I'm just curious what context or acronym you're using. Blit region. This is in GPU programming using Vulkan, and what we're doing is we're just copying an image into the thing. Ah, flitter. Okay. I had to read that like 5 times. Like, what are you talking about? Nicole, I was curious if it's just a designation you made or whether it is. No, it's an old term. Yeah, I think Abraxy's got it right. I remember using it when, Jesus, in the 80s. It was just something that was like how you had to do graphics. Wasn't it like a dedicated operation, Blit, I think, or something like that? I don't think it was an assembly operation, but it was something like that. Oh, and then we have to do copy image. Oh, okay, I already did that. Audio blit is band limited impulse train. No, yeah, I'd say it's totally different. All right, so all of this code yeah, it's interesting. In the back of my head, I'm thinking this can be vastly improved with some C++. And also, like I said, I think in C, this is easier. Because you don't have to type all these lines of code. You just like set the variables in a struct. Yeah, very interesting. Okay, so that compiles. All right, now, Vulkan engine. Vulkan engine, we are going to add now void engine draw background vk command buffer vk clear color value Wait, didn't we already do this? It's not getting too big. We're going to leave the synchronization command bar for management transitions and the draw function, but we're going to add the draw commands themselves into a draw background function. Yeah, these are in here, right? This thing. Yeah, this should have been just pulled out of it right away. Command clear color image. Yeah, it's that. And then I'm assuming that goes in here. Okay, let's make sure. I will be changing the code that records the command buffer. You can now delete the older one. The new code is this. This is the draw function? Where? The code that records the command buffer, you can now delete the old one. The whole contents, or? Are we waiting for the transition image, and copy image to image? Oh man, he needs to be way more explicit about where this goes. Okay, well, first off, yeah. We'll leave that there, and we'll find this. We'll grab that. No, yeah, this is different. This part's different. Yeah, okay, we'll get that. There. Okay, do this. Okay, let's make sure that kind of runs still. It should, because we just almost. Yeah, but now we have a different structure. So where's our draw? We still have to wait for the fence and reset the fence. Okay, I'm assuming we just replace all this. I'm just gonna... There's just no way. There's seriously no way it's replacing all of that. What the fuck? Alright, we've ran into a landmine in the code. It just very arbitrarily, we will be changing the code that records the command buffer. You can now delete the older one. Okay, well, where? Where does this go? You give me a function name and an exact edit, or do a diff or something. Alright, so I'm assuming it's something here. Let's just confirm VK end buffer. What is it like? See, this should have been pulled out into a separate function, man. VK and command buffer. So it's up to here. Okay, let's put a big space here. And then okay. I believe VK begin. I'm guessing from here. Yeah. Okay, so from here, get rid of this. Let's get rid of that. It's just that. So we didn't simplify the code. Okay. This needs to be cut up into a lot of little, like 3 or 4 little functions, man. Okay, so it goes here. Okay, but right here, you need to draw extent dot width. Draw image dot image extent. Wait, are those the same types? You can just do this. Just do that. They're both extents. You just set them equal to each other. So I'm missing some kind of hidden struct element. Okay, and then here, vkutil transition image. Okay, I'm gonna have to shrink this down. Nope, that won't help. I need to find that code again. All right, cool. vkutil transition image command swap chain images swap chain image index. Is there additional crap? Of course, there's always like 72 lines of code off to the side. Also, default parameters on a lot of these would really help. Like if you could set like the 95% of the time, you're just going to do these configs and then it just sort of like pulls it from a config. Yeah, I'd say that would make it a lot easier. Like if you configured all these options one time. You know, honestly, yeah, wait, why? So why can't you just like, all of these APIs are basically, you're doing all this stuff to kind of load, configure the graphics card, configure all this stuff, configure input and output chains, memory regions, things like that, right? So if you had something like a config shader, so it uses a GLSL, whatever shader language, but what it does is it sets up all of this shit, memory buffers, input output buffers, all that. And you just have a single call, sets all the options, sets all the configs, basically you code the GPU in this other language instead of these function calls. You have a bit of setup, you get your device, that's the most code you write. Once you get the device, you go configure with this and you hand it basically a shader language config. And it goes boom, and then you get memory buffers, you get everything you need, all ready to go. And it sets up all this stuff that I'm setting up, right? Like transitioning images, all of that. All these inputs and outputs, all these options, everything. Just have like a shader config language. It configures the whole thing. Internally, done, and then you basically get out, you just call some functions to get pointers to where you read and write stuff, and then you're good. Yeah, I don't know why they... Yeah. Yeah, just a shader language that configures it. Copy image to image, command, draw. Alright, I'm going to do the right thing. Alright, so you transition an image, transition an image. Alright, don't want to type that out and get it wrong. And then finalize it. I'm not even sure if that's the right place or right way to do that, so I mean, maybe I'll have to go look at the code. That's your draw function? Holy crap. That's a lot of bullshit. This could definitely be improved. Okay, so you transition the image. Transition swap images, swap chain index. Copy image to image, and then transition to swap chain image. Why 3? Okay, that puts them in the right transition line. It says the swap chain image left present, so we can... Oh, and then the... It's kind of odd that you do this every time you draw. Like this here seems like when you make the draw image, you should just configure it. Yeah, you're going to have that. And when you make the swap chain images, you go, you have this. And then this is the only transition you actually do. So you just like draw to the image and then do that. Right? Because if this is a layout configuration, you're configuring this image to have a layout as source optimal and transfer optimal. That should be done once. Like, why do you have to do this every draw call? Alright, so then you submit it. You wait for the semaphores to finish. Again, this part could be pulled into a function on its own. And then you present. This could be a function on its own. Yeah, this could be chopped up and kind of cleaned up a little bit better. What am I doing? Angry Punch. I'm learning Vulkan, which is kind of the new graphics API. For no reason other than to just kind of learn it. And meant for operators. Oh, interesting. One is a 2D and one is a 3D. That's why. Why? So Vulkan is, if you've heard of OpenGL, Vulkan's supposed to be the new way to do cross-platform graphics, right? And it has a reputation as being very difficult, And I'd say that's earned. It's definitely more difficult. But the counter, I would say, is that it's way more logically structured, right? Like if I read this code, I know exactly what's happening, right? Even though the code is complicated, I know I'm creating a command buffer here. I'm initializing these to have layout transfer destination optimal. Then I copy the image from my draw image into the swap chain. And then here I transition the swap chain into there. And then I end the command. So it's a transaction. That's all it is, right? Whereas in OpenGL, a lot of the stuff you did was just like behind the scenes, kind of happened without much interaction. You just kind of made buffers and did things, and they were copied for you, and you had no idea. Like, I'm going through the tutorial, I'm like, what the fuck is going on? Like, nothing's explained. It just happens. You have no idea, right? So it just as like a learning exercise to see how these are. But I also feel like it could be a really interesting exercise to kind of, how would you clean this up? Also, I'm just kind of curious, like, how people actually use this stuff. Okay, so not displaying. Did I botch the code for the draw? That we no longer do the clear on swap chain image. Instead, we do it on the draw image. Once we have cleared the image, we transition both the swap chain and the draw image into their layouts for transfer, and we execute the copy command. Once we are done with the copy command, we transition the swap chain image into present layout for display. As we are always drawing on the same image, our draw image does not need to access swap chain index. It just clears the draw image. And we're also writing the draw extent that we'll use for our draw region. Way to render images outside of the swap chain itself. We now get significantly higher pixel precision, and we unlock some other techniques. Okay. But it's not actually working. Oh, did I ever call draw background? No, I'm not calling draw background. Hold on. Wait. I'm missing like 2 whole lines of code. Right here. VK. Yeah. I'm just going to grab this. Looks like a great learning project. Yeah, it's not bad. I mean, in a lot of ways it's kind of useless. I think I wouldn't actually use it. It's far too low level. I mean, I do like it. I do like working with low level shit, but I also would rather just kind of hack on my own game, and if I want 3D, go find something that does it easier. But this guide is pretty good. I think it's just got a couple things where I'm like, where do I put this? What are you doing? I'm also kind of curious why we have to constantly... Let me put this in real quick. Why do we have to constantly reconfigure these image services? It seems like you should do that one time when you make them. Override it all so we don't care about what was the older layout. Yeah, weird. All right, now we're at shaders. Ooh, boy. This is one hell of a workout, man. Halfway through the Python book. Oh yeah, nice. It's interesting seeing and trying to understand other codes. Yeah, learning multiple languages is definitely the way to get better at programming. Let's see, Abraxi, to answer your question, a lot of programmers carry OpenGL expertise into Vulkan, so it ends up being the same buffer fest. Can you explain that more? You mean that they kind of do the... You mean like they just replicate OpenGL's sort of like behind the scenes magic kind of thing? And see, I was thinking that, and it's basically what I'm doing with my CPU graphics lib. Yeah, like this seems more useful as a teaching programming itself thing. Yeah, in a way. But so I think the thing that I'm liking about Vulkan is that it's very clear what you're working on, right? It's a lot of code to work on stuff, but like I know destroy fence, I'm destroying a fence that is attached to the device. I get the device from, I find a physical device, then I get a device from the physical device that I can work on. So this is a render fence, and here I destroy a semaphore. Here I destroy the swap chain. Like it's all there, okay? And then destroy the surface. So from the instance that I have, then I destroy the surface. Then I get the device, blah, blah, blah. And then I destroy the window. So it's basically object-oriented programming, right? Like the very first parameter is the thing you're working on. It's kind of clear what you're working on. Destroy semaphore, you know? Whereas with OpenGL, like if I were to rewrite this with OpenGL, it would be these first parameters would be gone. And then the only way that you know, and then also it would be things like just destroy locking thing, right? And the only way that you know you're destroying like a command pool versus a render fence versus a render semaphore or anything is that, well, that was the last thing you touched. So, oh, you just, if you connect two buffers in Vulkan, you get the two buffers, you actually connect them. And in OpenGL, it's like, well, the last buffer you touched, that's the thing that gets connected, right? Now, when we look at this code, I'm going to say 90% of this code is just bullshit struct settings. Not 90, let's say 40% of this code could go away if the configuration system was a lot better. Like I said, if there was like a way to pass in a config shader, that would be the bomb. Where you just write like a config and it's compiled and then snap, you got your stuff, right? Instead of these structs, because a lot of this stuff, what kind of buffers you have, how the buffers are handled, what the address of the buffers are, utilizing the same stuff where you have input and output parameters into a shader, same kind of thing. Yeah, all this stuff. Like if you look at this, right? So physical device selection. If you look at this, yeah, you can have a shader where you just say output is a device. And then you go physical device selector, select this, get the minimum version, get that, and then assign it to the output parameter, and then you get your device. Yeah, so see again, like this, boom, big chunk of code is just configuring a struct. Like a whole ton of code is just setting structs. And a lot of that complexity, I believe, is because Vulkan is a C API, so that's easier in C. In C, you don't have to do this stuff. You can actually have like very simple temporary structs that get passed, and then you set. It's almost like a keyword value function call system when you use structs like that in C. But when you come to C++, they have that stupid restriction that all the things have to be done in a specific order to match the fields, so it doesn't work as well. So people resort to like, 7 lines of code to make one struct. This crap. And so that definitely is what's making this way more complicated than it needs to be. Yeah, yeah. I'm kind of curious. Yeah. It's definitely interesting. Anyways, okay. All right, let's get a view into what is next. I think we're going to be stepping into making shaders. Okay. Running code on the GPU. Alright, so we're going to use compute shaders to write data into an image and then display the image to the screen. Okay, yeah, that's kind of interesting. Alright, Vulkan to execute code, we need a pipeline. Alright. Graphics and compute. Yeah, see, can you imagine if they had a config pipeline? Yeah, man, like a Vulkan config pipeline, and you just feed it effectively a config file. And it hooks all that shit up for you, and then you just get a bag of pointers out of it and result options and stuff. I wonder how hard that would be to prototype. How hard would that be to prototype it? You'd have to make a parser that can parse. I'd have to know way more about how this works, but yeah. Huh. Anyways, okay. VK shader module is a processed shader file. The driver does not accept shader code in GLSL directly. Oh, that's right. You need to have a compiler that makes it go to SPIR-V. You need to rerun CMake. It's possible to use HLSL instead of GLSL. I heard HSLO is actually a lot better than GLSL. Okay, so you bind things via descriptor sets. Okay. You do a compute pipeline. Okay. All right, so we're going to have a compute shader. It's going to do the compute. What do I got? In and uniform image 2D image. Okay. Let me store the image. Texel coordinate. Okay. You add a descriptor. Okay, so then we're just getting a shader to work. All right, it'll look like that. Okay. All right, he's going to want us to do I am GUI after that. I kind of really hate I am GUI. Okay. All right, folks. Well, I think I'm going to wind it down here. 3.5 hours. To get that to work is kind of weird. Kind of a lot. So I'm going to call it here, and we're going to basically come back tonight at 10. All right, so let me get you a link to this code. Actually, let me get this code committed.